Hello, hello. We are going to do a word wall today because who doesn't love word walls, right? My first part of the word wall is going to be over seedling emergence, and there's three key initial steps that the seed needs in order to emerge into a little plant. So the first thing that it needs, let's say you go to the grocery store, you get a pack of pinto beans, you get a pack of lima beans. They're not just going to all of a sudden turn into a plant. There's one key ingredient or material that it is going to need to start that germination process. And that is going to be water absorption. So the first thing that has to happen is that seed needs to absorb a lot of the water. Now, it starts out with little seed and it has that protective seed coat around it. So once that water starts getting absorbed into the little seed, what happens next? Dun dun dun. Pew. The seed coat bursts open, right? Because inside is the actual baby plant. But the seed coat is that protective part so that the plant does not get harmed. That was when you did the germination lab and you saw we soaked the seeds in water and you saw the seeds got a little bit wrinkly. That wrinkle around the seed was the seed coat starting to break open. So after the seed coat bursts open, what is the very first thing that comes out of the seed? Is it the shoot or the stem, or is it the root or the radical? Correct answer is, bam, the root. The root has to come down first, and there's two major functions of the root. Remember, the first thing is that it's going to absorb all the water. Whenever you water a plant, you do not water it from the leaf. You're always going to put the water directly into the soil or directly into the pot because the root's main purpose is to absorb all that water. Well, the other purpose is that it anchors it into the ground or into the soil because sometimes predators like an animal can walk by. Sometimes it can be wind that becomes very powerful and it could easily knock over the plant. So the roots are the anchor system so that it does not topple over. Seedling emergence. And now we have our next portion of the word wall, which my seed has now grown. I have a root system, I have a shoot system, and this is a happy, healthy plant. So if my plant is standing tall and upright, what kind of turgor pressure is this showing? Is it high turgor pressure or low turgor pressure? Correct answer is high turgor pressure. And another term for these cells that have high turgor pressure is turgid. Turgid means tough. It is standing upright. It is standing tall. Now, if I have my happy, healthy plant, what would the cell look like? Now remember, there's two organelles that deal with the turgor pressure. You have the cell wall and you have the vacuole. So when this is what my plant looks like on the outside, is my vacuole going to be really, really big, or is my vacuole going to be really small? Well, I can see if I have a happy, healthy plant, that means it's getting enough water. And if it has enough water, that means my vacuole is going to be very big. So this would be what my cell would look like. And in this case, the force of my vacuole is greater than the force of the cell wall. If you think back to the balloon demonstration that we did, the bigger the balloon got, meaning if we added more water, the more it was going to push against the cell wall. And that cell wall kept on forming more and more of a solid shape rather than collapsing in. Now, if I move down, now, look at my little plant. Now my plant is wilting because we did not give this plant enough water. So now in this case, what kind of turgor pressure is my plant experiencing? Well, when it was when it had enough water, it was high turgor pressure. So now, if it's wilting and drooping, that would mean it's low turgor pressure. He's not very happy. He needs some more water. Now, if it's low turgor pressure and my plant is drooping or wilting, that would mean that my cells are flaccid or just flat. So turgid is tough, flaccid is flat. My cell of what a drooping plant would look like would be kind of the opposite of my high turgor pressure. The vacuole does not have a lot of water in it, and you can kind of see the cell wall is starting to cave in because nothing is pushing against the cell wall, which is why the force of the cell wall is greater than the force of the vacuole, because now this would be like if my balloon had deflated. My cell wall is starting to collapse in, and it's going to start putting pressure against my vacuole. Now, we have a couple different types of stimuli going on with my plant. The first one, if my stimulus is lack of water, meaning if my plant is drooping because it does not have a lot of water, that's dealing with the turgor pressure. So my stimulus, remember turgor pressure is what's happening with the vacuole inside of the cell. So if it's inside of the cell, would that be internal or external? Bam! It would be internal. An internal stimulus, and my response is that it wilts. An internal stimulus, lack of water. It does not have enough water, so it's going to start to droop down. Now let's do an example with, we're going back over. Hope y'all like my transitions, because I don't have a partner in crime to help me with the camera. Okay, so in this case, it's going to be a happy plant, and I'm going to look at what my arrows are showing. I am showing that my stem is growing up, and I am showing that my roots are growing down. So let's first start with what's given to us. If my stimulus is gravity, is that an internal or an external stimulus? Well, is gravity on the inside of my plant or the outside of the plant? Outside. So that's going to be an external stimulus. Now, then we have the response is that my roots are moving towards the stimulus. So remember, if I have gravity, gravity is a force that is going down. My roots are also going down. So they are both going in the same direction. If it's going in the same direction, that would be a positive stimulus. Or I'm sorry, a positive response, because it's moving in the same direction. Gravity is causing the roots to go down. My stem is moving away from the stimulus. So let's take our fingers again. Gravity is going down, and what direction is the stem growing? Up. So if the stem goes up and gravity goes down, are those going in the same direction? No. They're going in opposite directions, and if they go in opposite directions, that would be a negative response. Now, the last thing is I need to label this tropism. So, if my stimulus is gravity, what would my tropism be? And I'll give you a hint. There's two different names for it. The two different names are gravitropism or geotropism. Now they both mean the same thing. It is a tropism, which is some kind of movement based off of our stimulus gravity. Two different words, but it does mean the same thing. So my tropism is gravitropism. And all of this deals with some kind of force, right? The force of gravity. My turgor pressure dealt with the force of the cell wall or the force of the vacuole. And then my seedling emergence, it dealt with the force of water. Water came in and it created the force to burst open the seed coat. And there is our stimulus response. Word wall. Couldn't think of the word for a second. It's a word wall. What are we doing? We're adding lots of words. All right. Keep studying for your test. Hope this was a good review, and I will catch you on the flip side.